So as you can probably see, I'm a big fan of these voltage regulator modules, switch mode voltage regulators, buck converters these are. They're all step down converters, so the input voltage is higher than the output voltage, although you can get step up. But I just thought I'd go through some of the weird and wonderful specifics of some of these units. So here's the first regulator that I bought, which impressed me mainly because of the price. It was just over £1 and that included delivery. As you can see, it's based on the LM2596 switch mode buck regulator chip, and it has a 330 microhenry inductor there and a potentiometer to vary the output voltage at which it regulates. Now this one looks very similar, but you may be able to see there that the chip is the HV version, and that means that it can take up to about 62 volts on the input, and a telltale sign of that is the 63 volt 100 mic capacitor there on the input. So you should be able to put a high voltage into this and get 5 or 12 or any voltage out by setting the potentiometer. Now this one's a variation on a theme. We've got the LM2596 again there, 35 volt capacitor in, so we can guess that that's the maximum. I think this was rated for 36 in actually. But this one has a dip switch, and if you can see, you've got 16 volts, 8, 4, 2, 1 and half. And so you set the voltage on this thing, the output voltage that is, by pressing the dip switches. So you can see I've put the 4 volt and the 1 volt switches across, so we should be able to get 5 volts out. Now the adjustment potentiometer there is just to trim that to bring it exactly to the voltage that you require. Now here's an all singing all dancing variant. Once again it's based on the LM2596 switch mode regulator chip. But here there's lots of input and output options. There's a 2.1mm DC jack input, and there's a USB socket for output, although I don't think this is separately regulated. So if you set the potentiometer for 20 volts, you're going to get 20 volts on the USB, so you need to be a bit careful there. Now, following the trend that seems to be happening now, there's a voltage meter, an LED voltmeter here. That's the chip that drives it. I/O options carry on. There's a 2-pin plug and a 2-pin plug there on the output, and there's also these multiple 2-pin link points where you can take multiple outputs from this thing to go to multiple devices. Here's another variant, again 2596 based buck regulator. This one's got an enormous display on it, also two switches here, so you can switch the display between the input voltage and the output voltage. Now here's a really neat little voltage regulator with LED display, and this one's not based on the LM2596. This one's got a little tiny chip on the back. You probably can't see it, but it's the MP2307, and that's the this chip here is the microcontroller for the voltmeter. Now this one doesn't appear to have any capacitors on it, but it does. They're on the back, and they're these large multi-layer ceramics there. They're quite tall, but I just wonder what the ripple output of this thing's going to be like without large smoothing capacitors. This one's got one pot there for adjusting the voltage and a switch there to switch between displaying voltage for the input and the output. Now this one looks a bit like the last one, but something is immediately noticeable, and that is that you have two potentiometers here. And when you see two potentiometers, you know that one is for voltage and the other one is for current. And by pressing one of these switches here, I can't remember which one it is, you can get the display to show both the input voltage or the output voltage and the output current. So this is not only a voltage regulator, this is a current regulator as well. And another telltale sign is this resistor here It's a low value, it's 0.05 ohms, this little surface mount one here. So we have a new feature on this one, and that's current regulation, and that's very useful for driving LEDs. Now here's another voltage and current regulator. This time it's got two displays, so you can see the voltage and the current simultaneously. It's LM2596 based. Now there are three pots on this one. You've got voltage regulation, you've got current regulation, and there's also a pot to set up these LEDs so that you can see when the current drops to a certain point, and that's useful for battery charging. Right, now this unit's really in a different league to all of the smaller units we've seen. This is the ZXY 6005 power supply unit. 6005 means it can supply 60 volts at 5 amps, so it's rated at 300 watts maximum. This has two potentiometers here, a voltage, actually this is the voltage one, and a current adjust. And uniquely this unit can show you, even when it's switched off, because it has an output switch, it can show you what the settings for these are. So currently voltage is set for around 5 volts, current is around 50 milliamps, and then if I switch the unit on, you can see I've got an LED on there. You can see that one of those has gone into limit. Here the current limit has cut in, so you can see that it says constant current there, and also the CC LED has come on. The unit won't go over 50 milliamps, and in order to prevent that happening, it's held the voltage down. So although we set it for 5 volts, it's only now producing 2.8. Now this unit has lots and lots of features, including the ability to calibrate the volts, the amps, to set various overprotections, so that's over volt protection, over current, over power protection, over amp hours, so you can tell it to only supply up to so much charge. You can set a period through which it will run and then switch itself off. You can update the data. You can tell it whether you want it to start up off or on. Normally you'd have it off for testing systems. You'd switch it then to on when you make this unit part of a permanent installation, and you can turn the buzzer on and off. And finally, this is the ZX 6005D, and that just means that it's got a digital data entry here. So you rotate this digital control, doesn't have any pots for volts and amps, everything is entered through this, volts, amps, all the overprotection settings, and in addition to the analog unit, this has 10 separate memories, so it's a much more advanced unit altogether. Anyway, that's a roundup of voltage regulator buck converters. In another video I might cover some more of the ones that have current control, specifically in relation to driving LEDs.